again. Okay, we have a MacBook Air. It's been previously worked on. The story it was a no power, and they worked on it. They got it to power on, but it does not power with the charger. So I'm just going to show you guys. It does power on with the battery. As you guys can see, with the battery it powers on. It starts with the battery, but it does not start with the charger. So I'm just going to wait for you guys to see that. Can you see that? It went back off, but it's going to come back on. Can you see that? Okay, so it does power on with the battery, but it does not power on with the charger. So if we are to connect our charger here, there is no communication on the charger. This is a 2017, so connecting the charger should start the machine. However, you don't have communication on the charger. And your PPDC in, I'm just going to show you guys. PPDC in, this is an 80.00165. Let's quickly open that. 80.00165. What is that? It is 000. Okay, that's it. Now our PPDC in, when we measured, we are getting, this is PPDC in. So we can measure for PPDC in here, and we are getting 16 volt. Yeah, that's PPDC in. However, let's fast forward to, let's see what we have on our PP3V42. PP3V42, it's 3.4 volt. Okay, that is very weird because initially PP3V42 was low. Let's see what we have on our PP bus. Okay, PP bus is 1.2. And okay, so PP bus is 1.2 instead of 8.6. We are getting 1.2 on our PP bus. What does it want? Oh, hi, how are you? Good, good. So we are getting we're getting 1.1 on the PP bus. That is, we're supposed to get 8.6 on that line. So let's quickly take the board out and see what is going on by the section of the ISL. So this is supposed to be a quick repair. You got a very clean one, yeah? Okay. Yeah, is it very clean? Okay. So let's quickly take this board out and then get to see why we are not having PPDC in voltage with the for PP bus to be created. And after we sort that out, we should have a working machine. Okay, what is out? Let's open up. We are going to open up our board, the schematic, give you guys a better idea what's happening and how we are supposed to get power to our ISL. So our ISL is going to be U7100. That is going to be the battery and charger IC. Let's open up our schematic real quick. It's 0.00165. Okay, here you go. Now let us go to U7100. That's the battery. So here it says PP bus supply and battery charger. So that is basically the chip that generates your PP bus voltage. So we are not with the device can power on with the battery, but does not power on with the charger. So let's see why that is the case. And then we just saw that we are getting 1 point something volt on our PP bus instead of 8.6. Here, instead of 8.6, that's what we're supposed to get. We are getting 1 point something volt on that line. Now let us see how that is supposed to be generated. Obviously, that is going to be generated by E7100. Let's walk around. Let's go around the working condition of E7100 and see why we do not have 8.6 on our PP bus line. Let's connect our charger. Let's just confirm again that we're still having the voltages present when we started. We had PPDC in. Let's see if we still have that. Okay, let's get another charging port. Peter, what to do for me after this? Okay, when you're free, I need you throw all of this away, just and get me better charging ports, eh? Okay, we have 16. Yeah, that we still have that. Are you able to capture that? Okay. Should I tilt it to you? Is that fine like that? Okay. Uh, 6.5. That's fine. That's our PPDC in. Let's see what you have in our PP3V42. Yes, that's present. And then PP bus. PP bus is still low. Okay, now let's see how our PP bus is supposed to. How are we supposed to generate our PP bus through the charger? So now let's walk our way to. Okay. So here it says we are going to do the tracing from the adapter to the ISL. So here it says from adapter. Here it says from adapter PPDC in. That is going to come through that will come through this line, and then it will go through our inrush limiter, and then we will get an output. So let's quickly see if we have an output from our inrush. So let's quickly copy. Let's see what we have on C7184. Let's see what we have there. So that will give us an idea if we have voltage here. That will give us an idea if we have if basically if this is opening or not. Let's see what we have on that. Let's copy that cap and paste here. Let's see if we have voltage on that cap. That's 7184, yes? Just confirm that. 7184, okay, yes. So let's see if we have voltage here. So having voltage there being present, PPDC in voltage being present there tells us that our Q7180 is opening. If it's not present, then we know Q7180 is not opening. So let's see what we have PPDC. Let's see if we have PPDC in voltage there. And no, so we are getting 7.9 volt. That's not supposed to be. We're supposed to get PPDC in voltage, just like what we get here, which is 16 point something, is exactly what you're supposed to get here, which is now, but what we're getting is 7.8. So let's go back to, so if we're getting 7.8 here, now here it says PPDC, the voltage is supposed to be 18.5 volt. That is exactly the voltages that you get at the beginning of the circuitry, which is your PPDC in. Now, if this is not opening, if we have issue here, if that's not opening, obviously that is why you will get less voltage there. So let us see why that is the case. So before we continue, I'm just going to show you guys another the board for PCH. Did you bring it? Okay. So this is another board. I'm just going to show you guys what I'm trying to say. So that's connected. This, by the way, this is a machine that's got a 40 PCH. The PCH got burned, but obviously our PP bus is going to be fine. So let's see PPDC in. We see we have 16.6. PP3V42. What we have 3.4. Now this is the cap that we're making measurement on. So that is exactly the same amount of voltage that we are getting here. Even though we get a slight voltage drop, it's very small. You see, that is 16 point something volt. However, what we're measuring here, it's almost half of it, if not more than that. We are getting 7 point something volt on that cap here. So what it tells us is that this is not opening. Yeah, that it tells us that Q7180 is not open. Now, two things we're going to do. First thing first, we want to see what is because you see the gate of that is going to be controlled by our U7100. So what we do, we will flip the board over, see how our U7100 look, and then what we did, we observe our U7100. I see also that has been replaced. It looks like it. Uh, okay, and we have a diode that is missing. Okay, so let's see what that diode is. That might give us a reason why we have an issue there. That is that diode. So that's our PPDC in. So that diode is supposed to feed R7105, which is then going to feed our U7100, which is our ISL. And that diode is missing here. So first thing first, let us install that diode, because what we will find is that is going to be pin 2 of U7100. So let us see pin 2 of U7100. You see that is going to be so we're supposed to get PPDC in from this diode, and then it will travel through R7105, which would then go to our U7100. However, what we currently see now, we do not have this diode present, D7105. So first thing first, let us install D7105 first, and then we continue from there. Let's get a donor board. Okay, let's first install D70. Let's install D7105. Okay. Okay, that's it. That's in its place. Let's see what difference we have now. We don't want to have our charger connected. The fan connected. We like the multimeter to do the informing, not the fan. Okay, let's see PPDC in voltage present. Okay, now let's see on that diode that we just installed, PPDC in, we have in, and then do we have output? Yes, we have output. Okay, now let's see what we have on our PP bus. PP bus is still 1.3. Okay, now let's see what we have here, and we are still getting okay, that, let's see that is now lower than what we had in the beginning before the diode was installed. Now we're getting 1.414. Okay, do we see our PPDC? Yes, we see our PPDC. Okay, let's trace our way back. We have now replaced this 7105, and this 7105, it's obviously we will get our PPDC in, which will go from here, from this pin here, and it's actually going to feed both the input of the diode, and then we're supposed to get output here. Yes, we are getting output here, but right now what we are getting, initially before the diode we were getting 7 point something volt on this cap here, and now we're getting 1.15. Okay, so what we want to do is first, because the ISL has been worked on, we will start by, I'm just gonna confirm something now. So we're not sure if the ISL was replaced or reflowed or what was done here. Okay, let's remove the ISL and then see what we get on that cap. Let's remove the ISL. But before we do that, let's quickly replace Q7180. But is this the one we took out from here? And the one we took out from this board? The one we took out from here, where is it? And the one we took out from here? Is it this one? Okay, let's see. Okay, so after that is done, the next thing we want to see is before we go around to check the working condition of the ISL, we will be first that since Q7180 is replaced, the next thing we want to do is to see what the state of the body is now, and then afterwards we want to replace the ISL. Then we can start making measurements, which is basically the working condition um, of the ISL. So first thing first, let us see what we now have on the output of our Q7180. PPDC in. What's happening? Let's check that. PPDC in. Okay, so is our Q7180 not good? Because we are getting a dancing voltage. Let's try that again. PPDC in. Okay, that doesn't look good. And the only changes we have made, it's with Q7180. Let's quickly remove it and see why we're getting that. See what we have now on PPDC in. PPDC in is stable with our Q7180 removed. So most likely our Q7101, Q7180 it's faulty. So we can use this one. Okay. Okay, that is in its place. Let's just make sure we don't have a short. Okay, let's see. What do we have on our PPDC in? Still going up and down. Switch to voltage mode. Okay, we have stable PPDC in. Let's see what we have on the output of our Q7180. Okay, we still have 0 volts. So now let us remove our ISL, because ISL is supposed to control the gate of our Q7180, which will allow it to open. Okay, ISL is out. Okay, before we replace the ISL, let us see what we get at the let's see what we get at that cap, which is C7184. Let's see PPDCA, what do we get? 16. Let's see that cap, what do we get? Okay, let's see that again. 0. Okay, that's expected. And then let's just confirm. C7184. C7184. That is just before Q7180. Let's go to Q7180. We have voltage there. Okay, yes, we do. Okay, so let's now put back, install the ISL. We hope that this ISL it's a working one. Okay, ISL is installed. Let's see what we have on PPDCA now. PPDCA, okay, it's PP342. Present, let's see output of the inrush limiter. Okay, we still have 0.9 volt. That's fine. The next thing we want to do is initially before we started, we could power the machine with the battery. Let's see if that is still the case. Are we still able to power the machine with the battery? Let's see that. Oh yeah, we disconnected the fan. Okay, so we still can power the device with the battery. Okay, cool. So which means we are still where we were. Now let's work our way to how Q7180 is going to open. Let's go to, okay, so here at the Q7180 we will have what is charger underscore a gate underscore division. Okay, which will then go to our ISL. Okay, now let's we have R7185 and R7186. That is going to be a voltage divide. Those are going to be voltage dividers. However, the R7186, the combination of the voltage division is going to open to ground by U7100, which is the ISL. So let us check the working condition of R7185 and R7186, because those need to basically divide the voltage in order to lower the gate here for our MOSFETs to open. So let us see what we, and then we also have the same thing here, which is R7180 and R7181. First thing first, let us see what is R7185 and R7186 looking like. Let's copy those. And R7186. 26. Okay, let's see what those are looking like. So R7186 and R7185, it's going to be this and that. So let us see the voltages that are on pin 1 of it. So first thing first, let's see the voltages on R7185. Does it have something to divide? Let's start from there. Okay, it has something to divide. And then on the other side, 0.6, that is actually working the way it should. Yes, that is actually working. Let's just see. Okay, that is actually working. That's fine. Okay, yeah, that is actually working because let's go back to that. So we're supposed to get a voltage division here, R7185 and R7186. And so the completion of that process is going to be done by our Q70 U7100, and that is actually happening. We are getting voltage division, and the way we're able to confirm that is we're getting 16 point something volt here, but we're getting 6 point something volt based on the resistance of both resistors, which is fine. Now the next one we want to see, just before we continue, we will also come here, but just before we continue, let us remove let's just confirm we don't have a short on the output here, which is R7120. So let's see, R7120, it's going to be this guy here. Okay, so let's see what we have on R7120. Our multimeter is set to diode mode, red probe to ground, and then our black probe. Let's see, 06, and then the other side, 06. Okay, so just out of curiosity, let's remove R7120. And let's see if we'll get any before we go to the other side of our Q7180. Okay, that is out. Let's now try it again. PPDC in present. Switch to voltage mode. PPDC in, just to confirm. Yes, PP3V42. That's fine. Let's see, and the output of PPDC in is still 0. See, 16. Okay. It's needed to confirm that we don't have a problem at the output of it, and that we have confirmed. Now let us go to the next, which is going to be R7180 and R7181. Let's copy that. R7180 and R7180 what? 85, yeah? Is it 80 and 81? Okay. Okay, so that is going to be this guy here and this guy here. Okay. So what do we have on? So let's see, R7180, flip to the other side, it's this guy, and R7181. Okay, let's see. Also, we have a missing capacitor there, which is on the current sensing line. Let's replace that first. So I'm talking about here, there's supposed to be a cap there, and that is missing. So let's replace that first. Okay. So let's see what we have on R7180. Let's connect our charger. Fan, please stay disconnected. We don't need the fan at the moment. Let's confirm we still have PPDC in. PPDC is still present. Let's see what we have on R7180. So pin 1 of it should have PPDC in voltage. And we seem to be having 0 volt. Okay, 0 volt is okay. That is supposed to be after our inrush limiter 0 volt. Okay, let's see something. So we are getting 0 volt there, and yeah, that is because of that's because this is not opening. Okay, fine. Wait, 0 volt. Let's see. PPDC in, present. PP3V42, present. Let's see, output of 1 point. Okay. Okay. Let's check our current sensing line. Just by the way, that's fine. 1.5, that is not fine. We're supposed to get 0 across. So yeah, supposed to get a reading like this. 0, let's see that. You should get 0 point something across. Yeah, but here we are getting what? We're getting, okay, now we are getting, our multimeter seems to be messing with us. One 1.4. Okay, that's not supposed to be that. Let's see what the time is. That's not supposed to do that. Let's replace that resistor. Okay, that resistor is there. Give it a bit of time to cool off, and then we can. We are still yet to measure the working condition of our E7100. So we just want to make sure that we address the working condition of our Q7180, which is also majorly dependent on E7100. But first and first, let's confirm that the working condition of we're just waiting for the board to cool off. Okay, let's check again. Okay, that is different now. Let's see. Ability 42. It's the output of. Okay, we still have 1 point something volt. Okay, fine. Now let's measure the working condition of our ISL, and also look around and see if any other component is missing at our ISL. Let's check this out. 16, 16, and out. 16. Okay, let's check out our charger DC in. Is that present? Okay, that's present. Charger AC in. Let's see if that's present. Yeah, it's present. Charger V3. Voltage frequency. Let's see, is that present? Three point three. Okay. Charger cell, not yet. Charger V. Okay, let's see what we have there. 2.8. Okay. Let's see, that's on pin 8. 0 point. Okay. As for the charger, okay, so that's it's present. That's present. So we have confirmed pin 10, 11 present. PP342 is definitely present. We confirm that. Charger reset L. That is definitely present, most likely. Charger reset L is present. SMBC okay. Yeah, that should be present as well. Yeah, that's present. Charger, that's for battery. Charger B gate. That's also 1.3. Current sensing. It's here current sensing for that's for battery. That's the current sensing for battery. Okay. Well, obviously we'll get, yeah, that's what you get. And then let's see what you have with our VDD. 5 volt. 5 volt, that's fine. Pin 20. We're also expecting 5 volt on pin 20. And yes, we do. And then charger L gate, which is okay. What do we measure at charger L gate? 0 volt. Okay. And then charger phase. We should get 1 point something volt. Charger U gate, yeah, it's expected because of let's see, 4.9. Okay, and then charger boot. Hi. He's asking, did you try to call? Okay. Is it the guy for the screen? Um, you have to come back. It's not ready. Come back. Tomorrow morning. We can give you a temporary screen, the one that is there now, and then you work with that, and then in the morning you come to replace it. Because I saw the one that you picked. It's got a thingy on the flex. Is that the one that he picked? Go check that one there. The one that is on there now. You can pause the video. Okay, so I'm just gonna go over what we what's quite confusing what we with this board. So I will go over what we did. So what we were having was we were getting no output at Q7180. So we then had to go to our schematic to find out the working condition of Q it's 7180. Now the way this is going to work, basically it's you will have voltage going in, which says here from adapter. Now when that voltage goes in, you have a gate. Now the voltage on this gate has to be lowered. You will get say you have a 16.5 volt here, and then it gets lowered by your U7100. Now, if you use 7100, if it's not lowered by U7100, what would happen is the voltage here will be stuck. The gate will not allow, the gate will not open, and you will not get anything at the output. So what we did was, as you guys know, so with the board, because this has already been worked on, okay, D7105 was missing on the board. We replaced D7105. That didn't solve the problem. And then afterwards, what we had to do was to replace Q7180. That didn't solve the problem either. So what we then had to do was to come back to U7100. We replace U7100. That didn't solve the problem. I'm just going to close that and then reopen that. So we replaced U7100 and that did not solve the problem. So it became confusing. So what I needed to do was I then had to check the current the value of R7185 and R7186 to be sure that they are doing their job. And yes, they were doing their job because we were getting voltage division at R7186. So we were getting, so the voltage division was taking place. However, this was still not opening. The gate was still not opening. And then I was looking at, I was trying to understand why that is. And then I checked for continuity between I checked for a short on that line. We didn't have a short on that line. I replaced U7100 and then I think I had to put in another U7100 and it still didn't work. And then I looked at the schematic, and from what I can see, from what it's here, we have a source, we have gate, and then we have drain. Source is present. The gate, the gate is functioning because the voltage is being lowered, but we don't have drain. And then I was asking myself why, and then I looked around the circuitry and I couldn't find anything that would prevent us from getting our drain. Then I then had to come back to uh, I then had to come back to Q7180. So the mistake that we made here was we did replace Q7180. However, we didn't have it pressed down. So it wasn't properly pressed down. It was just sitting, but there was no proper contact at Q7180. So even though it was replaced, it looks good, but there was no proper contact underneath Q7180. And that was why there was no output from Q7180. And it took quite a bit of our time because we had to obviously go over U7100 to find out if anything will prevent Q7180 from opening, and we couldn't find anything. We had to check for continuity on lines, nothing. We checked for short, nothing. We checked on using diode mode to check on the pins of U7100. Everything checked out, but still we didn't have output on Q7180 until we then finally we said, okay, fine, let's resolder Q7180, but this time we had to have it pressed down. So we did that, and now we have Q7180 is now opening, and now we have a functioning board. So fan is connected, and as you guys can see, and on our output here, on the output of our Q7110, so that is 16. Initially we were getting 0 point something, about 1 volt there, which typically meant that Q7180 was not opening. So guys, when you replace Q7180, I mean, sometimes because the way the way the chip, I'm just going to show you guys. I will show you guys something now. So this is how it played out. This is one of the ones that we replaced. So when you take Q7180 out, just be aware that you may have flat pads inside of it. So you may get flat pads. Now these pads that are flat, if you replace it, you may get partial contacts in the pads. So what you want to do is you either want to add solder, you either want to add a bit of solder to the actual pads, or you want to make sure that when it's installed, when you add enough solder on the pads on the board, and then when you are installing, make sure you press down, you make sure you press down the chip to make proper contact. Otherwise, you'll have the same runaround that I had here, which took me quite some time. But yeah, eventually that was quite a spin because we had to go to the section of U7100 to check out virtually everything on U7100. I'm talking about, so virtually everything on U7100 as to why our Q7180 would not open and we couldn't find anything. But eventually the problem was that we did not properly install Q7180 by having to press it down so that it makes proper contact. And after we did that, which was like the final thing we had to do, and then now you guys can see that now we have a working board. So right now this board is going to start with the charger, which is what which it wasn't doing before. I'm just going to plug it in again for you guys to see that it starts with the charger. Initially this board will only start with the battery but not with the charger. But now we can see that the board now does start with the charger. So now let's see with our battery. Let's see if the board still starts with the battery, because that was the issue we had initially. Let's see if the board still starts with the battery. Okay, yeah, the board still starts with the battery. Okay, guys, thank you guys, and that is going to be it for this one. I'll see you guys in the next one.